Example number 1, highlighting learning targets numbers 1.4a, 1.4b, 1.4c, 1.4d, and 1.4e. Take a moment, hit pause, see if you can match the listed property with the corresponding expression. Again, these are the properties of multiplication we have discussed. See if you can match them. So go ahead and pause. When you're finished, go ahead and hit play, and we'll work through them together. So beginning with the first expression, or in this case equation, we have b times 0 equals 0. Well, what's going on? Well, we have multiplication by 0. And if we remember about why the name was it describes what's being multiplied. Well, in this case, we're multiplying by 0, so we have the multiplication property of 0. Looking at the next equation, we have a times b times c is equal to a times b in parentheses times c. Now at this point we should be very familiar with this property because it's dealing with grouping. And when we're dealing with grouping, we know that we are working with what is being associated with. Again, think about our friend analogy from both the associative property of multiplication and the associative property of addition. Looking at the third equation, we have b times -1 equals the opposite of b, or negative b. Again, this describes what is being multiplied, and we know that we're having a multiplication by -1 resulting in the opposite, which describes the multiplication property of -1. Moving to the next equation, we have a times b equals b times a. If we look at what happened, we have changed the order of the terms. Instead of going from Danville to Lexington, we are now coming back from Lexington to Danville. The value has not changed despite the commute. That's right, changing the order of the terms describes the commutative property. Looking at the next equation, we have a times 1 equals a. Now the tendency might be to say, oh, this is describing what's being multiplied, a times 1. However, notice that that is only true for the multiplication property of -1. This a times 1 equals a is the one that I encouraged you to be very careful not to confuse with the similarly named property with addition. Let's look at what's happening. We have a, which has a value, being multiplied by 1, but maintaining its value of a. And when you think about why something was named, why the property was named, it's because it maintained its value, it maintained its identity. The a maintained its identity through its value. Once again, please do not confuse this identity property of multiplication with the identity property of addition. And then lastly, we can see that we have left, I think I'm just going to have to do a circle or an underline here. So I'll just put a box around it. We have the inverse property of multiplication, which is what is left. However, let's describe what's going on. We have a being multiplied times 1 divided by a, which is equal to 1. Now, if we want to change this a to a fraction, we will put a 1 in the denominator. We know that this 1 is in the numerator, and when we change the numerator to the denominator and vice versa, and multiply them, we have the reciprocal. Okay, we have the reciprocal that we're multiplying by the original number, and that is going to equal 1. Again, we're multiplying by the reciprocal, that word inverse, this word inverse referring to the reciprocal. And that is why we call it the inverse property of multiplication. And again, another example of why we have to be careful not to confuse this property with a similarly named property of addition, the inverse property of addition, because the inverse property of addition is adding the opposite. So make sure that you distinguish these properties from the properties of addition.